Problem 3, page 547. Make sure you've read the problem and possibly even section 19.1 before you go any further. It asks, what's the internal resistance of a battery? So we have a car battery which has a nominal resistance, a nominal voltage of 12 volts. And we're connecting that to some external load which has resistance R, and that's our starter motor. So you turn the ignition in your car, it closes this circuit, 12 volts in your battery is connected to the starter motor. Okay, well, the current that flows through the external circuit also has to flow through the battery. And a real battery is going to provide some resistance to the current that has to flow through it, the internal resistance. So if we think about a car battery and what it looks like, we have, it's a box, and sticking out the top of the box are two metal poles like that, and these are the terminals of the battery. They're connected to big thick wires that send electricity off to the starter motor, the car, headlights, the radio, all the electronics in the car. And in this battery itself has a resistance to all that current flowing through it. So if we stick a voltmeter across the terminals of the battery, we're going to measure the voltage that the battery gives. Okay? A better way to model this circuit is just say we've got the 12 volts that the battery provides, and then there's a little internal resistance. The internal resistance of the battery tries to prevent current. And on either side of that, here are the terminals of the battery with the resistance inside the battery. And then this gets connected to the external circuit, which in this case is our starter motor R. Okay? And these two blobs here represent the terminals of the battery there, with the resistance inside. Okay? So make a little space. We don't need this anymore because we're going to use the slightly more sophisticated circuit down here. If we just look at the battery by itself, if we had the battery just by itself, it's not in a closed circuit, no currents flowing, we're going to measure 12 volts. This is going to be 0 volts. And this is going to be 12 volts. But as soon as we connect a circuit, current starts to flow. That current is going to give up some of its energy as it flows through the internal resistance of the battery. There's going to be a voltage drop as the current flows through that resistor. So in this example, the terminal voltage drops to 8.4 volts when the current is flowing. So now what we've got is that it's 12 volts here, the ideal battery within the real battery, but it drops to 8.4 volts at this point here. And then we go through the external resistor, the load, whatever the battery is powering, and then we get back to this side of the battery and we have 0 volts. Applying the loop rule. Now, what this means is we have 8.4 volts across this resistor, the external load, and 12 minus 8.4 is 2.6 volts, is the voltage drop across the resistor, while some current is flowing through. So the current that flows through, we're given that to, it's 75 amps. So the voltage here, the current of 75 amps times the internal resistance is the potential drop across the internal resistance, 2.6 volts. And similarly, the voltage drop across the load, the starter motor, is the current times the resistance, and that's this 8.4 volts. The two add up to 12 volts, which it should. If you apply the loop rule, we start with 12 volts, we lose 2.6, we lose another 8.4, and we're back to 0. And the current's the same for both of them because this internal resistance of the battery is always going to be in series with whatever's outside. And so we can solve for both resistances. The internal resistance is 2.6 volts divided by 75 amps, which is about 0.03 ohms. And the external resistance, the resistance of the starter motor, is 8.4 volts divided by 75 amps, and that's roughly 9 ohms or so. 0.9 ohms, very low as well. Nope, that's wrong as well. You can do that arithmetic. But notice that the internal resistance of the battery is very low, and that's how you want it to be, because you don't want all the voltage dropping across before you've even got anything out of the battery. So this, you would want it to be low so that most of the voltage drop and most of the power dissipated in the circuit is actually in your device, your starter motor or your headlamps or your radio or whatever. You don't want to be wasting it all inside the terminals of the battery. All that will basically do is make your battery get hot and explode. So never short circuit a car battery, because it'll just get hot and start leaking acid. Not a good thing. So the internal resistance of the battery is usually small. It's always in series with what's outside, and there's a voltage drop across it, but you're only going to see that when you start having a current flow, when you close the circuit by connecting the terminals of the battery. And if you think back to the experiment you did with Ohm's law, when you had those wires and you were connecting to them, you saw that voltage drop on the voltmeter when you connected the circuit and started current flowing through it. And that was a result of the internal resistance of the batteries you were using there.